Okay, here we go. Number 4. A classic two proportion z-test problem. Um, so if I was a betting guy, which not normally I am, but in this case I probably would, you're probably not going to see a free response two proportion z-test this year, but you'll see one. Certainly you'll see it on the multiple choice. So you'll probably see some sort of a sample test, a means test, or even a matched pairs test potentially on the free response, or it could be a one proportion z-test. Anyway, all right. So you read the problem. You got 1,000 volunteers randomly assigned to one of two groups. Half the volunteers assigned to experimental group that took a low-dose aspirin each day. The other half assigned to a control group took a placebo. At the end of 6 years, 15 people who took the low-dose aspirin developed colon cancer, and 26 people who took a placebo had developed colon cancer. At the significance level of 0.05, do the data provide convincing evidence that taking low-dose aspirin each day would reduce the chance of developing colon cancer among all people similar to the volunteers? Okay, so here's our 2 prop z test. Name the test. You have to define P1 as the proportion of aspirin users who develop colon cancer, P2s who placebo users who develop colon cancer, and there's my hypothesis. Because we wanted to know, is there evidence that taking aspirin would reduce, there's the key word, the chance of developing colon cancer. Okay, so you've got to make sure you get these words in for P1 and P2. Again, if you use P hat in here, you're toast on scoring. Okay, over on the side here, we went ahead and just figured out what in the world is N1 and P1 hat and those sorts of things. Conditions. Both, we want to say our normal thing, both samples are randomly selected. But again, because this is an experiment and we've done this in class a couple of times, we have to do more than just saying the samples were randomly selected. But again, it's an experiment, so they weren't randomly selected, they were volunteers. But what do we have to have? We have to say both groups were randomly assigned the treatments. Okay, so if they're randomly assigned the treatments, then we're good. Okay, 500 is certainly less than 10% of the population. Both samples are independent of each other by how they were randomly assigned to the treatment groups. And then you have to check each of these conditions to make sure that the samples are large enough, so you got to hit on those. Okay, so it's okay to proceed with the test. Okay, now I'll tell you this. The conditions, like we said in class, that they checked on the actual rubric was this guy right here and this one right here. And if you just said random assignment, you didn't get credit for it. Or if you just said randomly selected, that you didn't get credit. If you said randomly assigned to the treatments or randomly assigned, you did get credit for it. So you got to get that in, and you have to verify or check each of these conditions. Okay. All right. Next thing, we're okay to proceed with the test. Remember, we pooled the data for a 2 proportion test. We add the number of successes in this case, people who develop cancer. Gosh, that's terrible. In each case, over 1,000, which is 0.041. Here's my z-score formula. If you plug the data in, which you actually don't have to, but you get a z-score of -1.75 and a p-value of 0.04. And since the p-value is this, this is less than 5%, I reject H0. There is evidence that taking low-dose aspirin reduces the chance of developing colon cancer among, I shouldn't say this group, among, go back up to the question, among people similar to the volunteers. See, and if you always go back to the question, you'll get this right 100% of the time as to what they're looking for. And plus, if there's a question that needs to be answered, you'll be able to answer that. Reduces the chance of developing colon cancer among people similar to the volunteers. Okay, there you have it. This average on this problem was, believe it or not, 1.5. I don't see how it's so bad. Although, after reading a lot of these, I really do see how it's bad. Um, because students didn't do things like define these properly. They didn't get the conditions. They didn't do a good job of this. Okay, and if you do bad enough on that, you get a 1. So there you go.